going to ask everyone to come over to the panel area, which we are going to start in a minute. All right, so this panel is the science requirements discussion for the personal space weather station. And so far we've been trying to talk about how we might design a SDR system for this personal space weather station. We've been talking about magnetometers, but one of the questions that keeps on coming up is, what are the specifications? What does this thing need to do? And then we try to answer that, and people say, well, what are the science questions? So it turns out that this is a bit of an iterative process, because as we explained yesterday, we saw a presentation from Tom McDermott that showed that if you want this 1 meter resolution for the system, the storage capacity and the requirements to do that technically, it's just not feasible cost-wise for a large distributed system of personal space weather stations. And yet, there is important ionospheric science that could be done at that 1 meter scale. But we also know that if we look at Tom's chart and we say, well, we can only get things at the tens of meters to hundreds of meters scale, that's possible. We have good ionospheric science that we can do with that. And so this is to try and narrow down. I'm going to introduce some of the science objectives. I'll give the science objectives and the questions again right now. And then I will hand the microphone over to Ward, who will help moderate a conversation. And so we can take input from the panelists and also input from the audience here too. There will be some microphones that we can pass around if you'd like to comment. I would love to introduce the panel. So I'll just start with myself. I'm Dr. Nathaniel Frissell, Whiskey 2 November Alpha Foxtrot from the New Jersey Institute of Technology. I am mostly an ionospheric physicist, radiophysicist. I've done magnetospheric work as well, and I really work on the border between the amateur radio community and the professional science community. And I'll just pass the microphone down.
Okay. So I'm Phil Erickson. I'm with MIT Haystack Observatory, same place as Larissa, although I know less than she does. I do ionospheric and magnetospheric research, and also have been doing radio science for a long time. So a little more of the science end of it, but technical too. So I get to see the user end from the science community also pretty much every day. So that's what I'm bringing.
I'm John Ackermann, N8UR. I'm affiliated with TAPR. And I can't legally or morally call myself an engineer, but we do a lot of engineering of software-defined radios and time and frequency systems. My main interest is time and frequency, and the clock system for the space weather station's kind of my main focus.
My name's Tom McDermott, N5EG, and I've been looking at some of the technical requirements for the SDR receiver and trying to analyze a little bit numerically what we think it might need to do versus what we'd like it to do.
I'm Scotty Cowling, WA2DFI. I'm a Vice President of TAPR, and John also is a board member of TAPR, and past president. And currently work for Zephyr Engineering. We do FPGA design work and embedded systems work, and for fun on the side, we do software-defined radios.
I'm Bill Liles in Q6Z, and I play. But I try to do it with some credibility in terms of science, calibrate equipment, etc.
My name is Hyomin Kim, professor of physics at New Jersey Institute of Technology with Nathaniel Frissell here. I do magnetospheric ionospheric physics, mostly using data set from satellite and ground-based instrument, usually magnetometers and particle detectors, to understand how the solar wind affects the magnetospheric environment. I've been visiting many different places for magnetometer installations, so I think that's why I'm here, I guess.
Okay, so my job is to more or less moderate the discussion. I have to start by saying this is a marketing discussion, okay? Not a hard engineering thing. Welcome to marketing, 3 during minimum, okay? We have 45 minutes to talk about objectives, and what we're really talking about is high-level stuff. the actual ascertainment of deep requirements is going to take a lot longer than 45 minutes, and we're going to have to sort out, we're defining a product here. So this is really a marketing meeting, and we're technical representatives from different constituencies that want to see this product built. So every once in a while, I won't add a lot or get in the way, but if I sense that we're going down a rabbit hole, I'll just say rabbit hole and try to reel in the offending rabbit, and we'll keep things moving along. So hopefully you'll notice that there are no PowerPoint, okay? So no death by PowerPoint, and hopefully we'll keep ourselves short, as I should do. So, Nathaniel.
Quick observation to keep things moving. There's a handheld microphone for each table. Ward, they have one. Ward is permanently wired, so you don't need to listen to it. And we have a mic runner here for questions from the audience. We ask to ensure that everything gets recorded.
Go. Okay, so Nathaniel's going to throw the first fish in the water, and away we go.
All right. This one's stronger than the other one. Okay, so just a reminder, there's a PDF on the HamSci agenda page right at the top that has the objectives and science questions we already talked about yesterday. I'm just going to start with the investigation objectives that I've already defined through my discussions with Phil and Ethan and Hyomin and a few other people as well. And so objective 1 is to characterize the ionospheric and geomagnetic response to space weather events with sources from both below, like Larissa was talking about today, and above the ionosphere from space, solar flares. Objective number 2 is to characterize ionospheric variability in identified sources, both during quiet and disturbed times. And remember today, we talked about how we generally have a good understanding of space climate, these 11-year cycles, diurnal cycles, but we don't understand the hour-to-hour, minute-to-minute type of variation. And then 3, determine the impact of space weather events and ionospheric variability on terrestrial HF communication systems. So I guess the first fish in the water will be, what do you think about these objectives, and should we add or change any of them?
Well, I also noticed that some people have added a thing or two. I can't read that far away, but I know that there's something on the board for that first number 1 and first number 3. So maybe if anybody who put those up has a particular comment relating to that, that would be useful as a way to start.
Well, I wrote on number 1, so I'm one of the persons, and I can't even read my own writing.
Excellent.
My question was, can we help find out whether the ionosphere works the same when signals are coming down as when they are going up at low frequency? We have a lot of experience at VHF and up, but not so much at HF and down, and there might be some interesting physics.
I know there is. If Ethan were here, he has a figure that I've used for him that basically the ionosphere is birefringent, okay, in that the magnetic field angle makes a difference, and it's not the same going either way. And if you do ray tracing, sure enough, there are paths that don't end up the same place. I think maybe for the operators in the room, one of the things that is maybe a challenge here, but an opportunity, right, is that when I've looked at those refractions, if the refraction moves a little bit off where you are, you may lose touch with it, all right? In other words, your individual station isn't going to hear that path because it is now one of the modes has refracted over here. But if he's over here with a station and picks it up, if I analyze them jointly, maybe I can figure out some of that refractive change.
Okay, next comment on the subject.
Yeah.
Well, I have a comment that kind of relates to this. Maybe a basic comment that came up earlier is, do we want a transmitter on every station? Because what I seem to hear, what you said, is that it's possible for one transmitter to transmit or ping and many, many, many stations to listen to the result of that. Is that sufficient, or is that not
Okay.
insufficient?
I can give you one analogy. I'm working on a separate project involving meteor radar work where one is trying to go from a single transmitter and a receiver to a MIMO situation, which you can find in routers, right? Multiple in, multiple out. One of the things we figured out from an engineering point of view is that people don't like transmitters, but they like receivers if they are a person who knows nothing about radio, okay? So the one transmitter, many receiver deployment is often a lot easier than the many transmitters and many receivers, because people will put a receiver out, even if it's an inefficient one. And if they walk up and they grab the wire, it doesn't matter. Whereas if they're transmitting, you know, you have to give them a warning. We found that statistically it's just about as good to have one transmitter and many receivers. So if we're going to put effort into doing things, increasing the density of receivers might be something that is the first thing and is tractable.
Okay. Other question? Other comment from panelists here?
Yeah, the first question, you have to have an active circuit. Can you monitor anything passive? Because you have, you know, that gives you a lot of opportunities for much wider bandwidth observations. Is that feasible? Do you require an active?
We had a conversation about this before, I think. Want to throw something about that?
I think so. For most of the work we do, it's good to have an active source, like listening to WWV or a CODAR system or something like that. There are certain instruments. There's something called a rheometer, which is a passive instrument and doesn't require any, you're just listening to noise from space. That instrument's less popular these days, but it is something that all you need to do is receive.
Well, maybe one other thing to throw in there is that signals of opportunity is something that we use. People use passive radar. They use FM transmitters to look at the ionosphere. So in some sense, we can use existing signals without having to have this collective begin by having a set of transmitting as well as receiving signals. I think the low-hanging fruit is to begin with using up all the signals out there in the environment that we already have, and then see what's missing from that. And version 2.0, looking at somebody over there, is to fill in the gaps.
Okay.
Okay, but what I want to go off of that is back something that was said yesterday is currently we don't sample. I'm a CW guy. I don't know about this thing. Okay. Yeah, well, I don't have one. We don't sample the ionosphere nearly at a finite resolution to figure out most of the things that were raised this morning. We just don't have, and so however we think about doing this, whether it's one transmitter, multiple receivers, multiple transmitters, and even more receivers, we should think about how are we going to go about trying to get enough sampling around the world, especially when 3/4 of it is ocean, where we won't get any samples, to actually get some data. So back to Rade's opening comments is, if we're going to define a product, what is it that we can actually put out there, no matter how many receivers we need or transmitters, that can actually start to get a handle on that? And so is it trying to use signals of opportunity as oblique sounders, which is one of the things that was been discussed? You know, what is it that we actually need? I mean, we can get the weather at the ground, right? There's lots of people who report that. And there's a whole crowdsourced way of doing that we can tap into. But now we don't have enough resolution of what's happening with the ionosphere to know what to do with that data.
Okay. In order to keep things kind of moving along and get all the other objectives, I'm going to wrap this one up with the statement that we need to determine a minimum source and a receiver density to perform useful science here. So that's a question we have to ascertain before we can go on with the requirement.
Yep, and that also is going to require us to get in touch with the modeling community, not just the observational community. We don't really have a lot of ionospheric modelers represented here, but they're going to have their own, throw modeling down. That's something we need to do our homework.
Okay, second objective. Nathaniel, what do you got?
Objective 2 is characterize ionospheric variability and identify its sources during both quiet and disturbed times.
Yeah.
What was your question, Ward?
No, I just wanted you to go ahead and kick off the discussion of objective 2.
Okay, so the objective 2 is to characterize ionospheric variability and identify its sources during both quiet and disturbed times.
And you have all the red and the other stuff written down?
I don't, so that needs to come from over there. So I think that what we were asking people to do is, if, so yeah, this battery's cutting out. So are there comments from the audience? Someone who's written something down for objective number 2 there. Are there any comments from the audience regarding that?
There's a blue and a purple there. I don't know what.
Blue is, do certain ionospheric disturbances have characteristic signature effects on signals going through them?
Okay.
Purple is distributed WWV/CHU, Doppler something. 2024. Yeah.
To answer the first question, do ionospheric disturbances have put information onto signals traveling through them? The answer is yes. So the two easiest ways to see this, one is by changing amplitude. So as a traveling ionospheric disturbance goes overhead, and if you have ionospheric refraction going underneath, going through it, that will actually cause the rays to focus and defocus on the ground. So you'll actually get a periodic louder signal being received, and then quieter signal being received. And you can see that from many different receivers. The other signal you see is what we saw with the Doppler shift signals, and this is arguably a little easier to measure, or maybe more useful, and that's showing the uplift and downlift of the ionosphere.
We have a comment here.
Okay, so it seems like the things that we actually can measure are amplitude and frequency and phase. And polarization, and then of course fix things like geographic location, and maybe antenna pattern and feed line and antenna system loss. But those things will be fixed, so I really want to focus on those. But there's really like 4 things that we can measure, right? So those are the things that we have to figure out exactly to what level to what resolution, what dynamic range, and what minimum levels we need to measure them. Correct?
I think there's one other complication that we ran into that I don't know that has been addressed by these networks yet, is that you just mentioned antennas. You just had mentioned feed lines. You're talking about the entire system, all right? Up to this point, a lot of the detections have been 1-0. Either the path was open or it wasn't. But we weren't talking about people who took the time to calibrate their polarization of their antennas, or to even know what the patterns were in the first place, the wire hanging above the wall. So what level can one go in terms of specifying that without getting the community to say, that's too much work, I'm not going to do that? How you set that balance is something that I don't know, but that requires some thought here.
Well, it seems like we could measure frequency and amplitude. Well, amplitude will have to be calibrated, and phase also, because the length of your feed line and all of that is going to, and it's.
It needs to be calibrated. The question is how much.
But you might be able to do it with a known common source and a known fixed location and known time, and then you can calculate the rest.
So I agree. I think whatever total system we design, not the system at a single installation, has to be very non-homogeneous. We will never have everybody having the same equipment, no matter how good of a set we make. How inexpensive, everybody's going to have different things. And so we have to know that whatever standards we put out there for calibration or whatever, everybody's going to be different, and the system will accept the different type of data from those.
Right. And I've wondered, and this is something I'd like to keep working on, when looking at data like the RBN or WhisperNet, people ask me, do you know what type of antenna they're using? Do you know what type of receiver they're using? I'm like, no, I don't know. But can we look at the data as a whole? So the data from globally or all over the US, and can we somehow invert backwards and determine some calibration from that uncalibrated data?
Yeah, I would expect that there'll be several revisions of the project, right? Where we'll come out with a simple, version, and then we may say, okay, in version 2 we want to study a particular thing, And, so we need circular polarization on antennas maybe. And the key is to be able to document in the metadata what version of the received system that you actually have, so that the data is then meaningful to analysts, which, it may be 2 years later before you go analyze the data, and you've got to figure out which data set was taken with what kind of equipment.
I would point also that the statistics of large numbers means that people who do large data sets, a lot of those differences wash out if you have enough density of measurements.
Okay. And I wanted to ask, you are dealing with magnetometers. You talked about calibration during your presentation yesterday. I wondered if you had some questions, having a lot of uncalibrated.
Well, so basically the magnetometer that we're going to propose is just commercial off-the-shelf type parts. So they are supposedly all calibrated, but who knows? So we have to make sure that we provide reliable data set which are completely compatible when you compare data sets. So I think that's very important aspect of this type of like largely distributed type of network, type of sensor network. In terms of the calibration itself, we still need to think about it, how to do it, like for especially, well, as a scientist, I've been dealing with a single magnetometer for a certain project. So that was done in the lab, but we're talking about a bunch of different magnetometers, right? So we have to come up with, for example, like magnetically clean place with some good shielding case where you can actually manipulate some sort of zero field effect, so you can actually calibrate sensor properly. But that's technicality. We have to think about it. What's the other thing that we have to make sure is that every place will be different. Some people may have not apartment, but like small backyard, really big backyard. So we have to come up with good. That's what I'm thinking about, like good documentation to describe. This is what you need to do. This is what you need to check to make sure that the sensor is not measuring something that we don't really want.
Yeah, one of the key questions I think will be, can the project create some calibration standards that folks can use to identify any issues they may have with their equipment? There's easy ones where the equipment can self-calibrate. There's more difficult ones such as magnetic field, antenna polarization effects, or maybe feed line delay differences that might require a physical standard or something to ship around. Is that something that you've looked at?
We do need to look at that. Also, I consider software algorithms to be a calibration standard, all right, to define some kind of way to analyze the data in aggregate that helps one pull out the calibration parameters as a whole already. So that's just part of the category.
We have one comment from the audience.
Okay, so when if we have magnetometers that need to be installed correctly, or else we're going to get strange data out of them, is there an easy way to add a test program to this platform so that a user can hit a button and see if there's a problem with their magnetometer?
I think that's a very good question. Yeah, as I mentioned, as a scientist, all the projects are really like specific project is oriented. So you build a magnetometer and then you go to a test site, you just test it, make sure that that's what we expected. So this is a very different approach. So we just distribute like a bunch of magnetometers and expect those data sets to be all reliable, which is not going to happen. So yes, we have to come up with very good test procedure. When it comes to testing it, like by pushing a button, I have to think about it. It may not be that easy because of the condition that I just mentioned. But everybody will have different conditions. So
we do have a general idea of what direction the main background field should be, right? So we should, no matter if you're measuring all three axes of the magnetometer,
good point, yeah,
you should be able to automatically rotate it using a trig rotation.
So
Call those sanity checks. Yeah.
We have a model like based on dipole model called IGRF, International Geomagnetic Reference Field. You go to website, you just type in your geographic information, latitude, longitude, and year. Then you come up with expected value of X, Y, Z. Then you compare that value to your magnetometer value. That's one of the sanity check, but that doesn't really tell you your noise condition. But you can actually tell whether your sensor is properly oriented, for example.
If we get enough density of magnetometers, can we use the mean that we get so that you should be in this range based on the 10,000 other units that are out there?
Right. So I'm using analogy many times. Google Map, for example, you are driving 60 miles per hour at an interstate. If there's one car stopped for fixing something or whatever, we should not use that information. We have to rule out that information, right? Something like that.
I think even in the scientific community, there's a project called SuperMag, which ingests magnetometer data from ground magnetometer stations all over the world. And I think they have automatic routines in there that make sure that the data is pointing in the correct direction.
Right, but that is not sampling everywhere at all times, because otherwise we wouldn't be interested in doing this. So.
Okay, I'm going to call rabbit hole, and we're going to have to move on to the next thing, but I think I'll throw in one thing. There are other citizen science projects out there that have collected a lot of data, and there are probably things we learned from those projects about dealing with the large and rather noisy data set. How do you extract useful science out of that? So,
can I just make one from a 10,000 foot level to go back up?
Go for it.
Is that it seems like there's three things that we have to deal with. One is, what equipment are you using? Two is, how did you install it? And three is it working right? And if we can determine whether the second and the third one are correct with automatic routines, then that's good. But like I know in Arizona, when you register a repeater, you have to tell us as the coordinators how high it is, what kind of antenna you're using, what's the pattern, what's the ERP you're putting in. You have to, and so I'm presuming that our stations are going to all be registered. So they're either that or maybe this registration data will appear in the metadata, but somehow we should know that this data originated from these physical sensors. Then only the other two parts remain. If we can figure out a way to calibrate those somehow, then we're in.
Okay.
We're in.
All right, thanks. Obviously, we could talk about this for a very long time. Objective 3, Dr. Frissell.
All right, Objective 3 says, determine the impact of space weather events and ionospheric variability on terrestrial HF communications systems.
So this is the one where the community out there, this is the impact of the things that we learned about the ionosphere on the hobby, for example. So there's more experts in the room about this one. I'm interested. What do you guys think? What would make a difference to you?
The added comment up here, number 4, seems to be study the effects of initial shock on HF, MF, LF communications or propagation.
So how about the idea of integrating Whisper into the Space Weather Station? Is that because it seems like you've got the network already, or a part of it, so you want to know what propagation is, you look.
Yeah, no, I completely agree. And this is something that kind of was my original idea. You get an SDR, you sample all 6 or all the ham bands simultaneously, just snarf it all up, run it through a Whisper decoder, an RBN decoder, a whatever decoder, and ship it off to all these pre-existing networks. So we, complement those networks.
I have the Whisper guys come up to me every year at Hamvention for like the last 3 years begging for an all-band Whisper receiver that they can just get the data from everywhere.
Yeah, that's
Reptile will do that. There's a firmware load there's a firmware load for the Red Pitaya that will scan all 8 bands and automatically upload the data. You plug it in and it starts doing it.
But we should do that too, right?
Yeah, I would think you might want to annotate the responses with the fact that this is a space weather station that captured the data. It might have absolute receive sensitivity data that perhaps many of the other receivers do not have. You know its position accurately, you know its certain responses. And so if it's possible to annotate that information, you may gather higher quality data as a result.
Okay, so Whisper at my house, since it's all open source, is not standard Whisper. Go figure, Phil.
Go figure.
Yeah. So I actually pull out what the noise is on that because the noise is not reported in the Whisper, and yet that's very important for doing some studies. Okay, but that's easy to augment to it.
And let's get back to something that Scotty just mentioned. What he had a member of the community come up and say, "I'd like this because I want to know which bands are open where I am." All right. Right. I think that we need more canvassing of the community to figure out what are their hot buttons, right? What are the things that does fading make a difference? You know, maybe that's only interesting to me as a scientist. So that's something that I'd like to hear more about, I guess.
Yeah, just what you just mentioned, Bill, is that we have now identified an interesting question that the amateurs have. I don't think I've seen yet a corresponding list of hypotheses that scientists have identified. Like we should have a wish list from the scientists saying, we'd like to be able to figure out this, and prove this or disprove that. A list of example things, because that's one of the first things you do, I believe, when you're setting up a space mission, setting up a new lander or something. You figure out what the science questions are you want to ask. Now, I suppose it would be possible to inadvertently over-constrain or set your sights too small. But the problem is, if you don't do it, you run the risk of going around in circles. Well, how much do we need? Well, what's the question? Well, I don't know. How much can we do? I mean, you're going around in circles. So I think it would be good if we could identify from our modelers, our space scientists, our astrophysicists, a list of hypotheses that they have, I mean, Larissa can help with this, Nathaniel can help, Phil can help. I mean, let's get that list from the science community, as well as knowing what the hams want to know.
Well, this is a Venn diagram with what do we want and what can we afford, and the intersection is where we want to be.
Right. And now the PDF that's on the web that has these three objectives is set up along the lines of a science traceability matrix, which is the very first thing you do. I'm doing 2 CubeSats. That's exactly what you do. So when you guys look at this PDF, that middle column is a start at what Bill was asking for, was some topics that we want to look at. But that's what we need people like Larissa and others to help add to, refine, all right? But you're entirely right. That's part of the dialogue.
But I think this refers, what you made refers to kind of like, well, I'm the ham that's going to set the weather station up. What do I get out of it?
Yeah.
I want something out of it. I want propagation information. I want noise information. I want prediction. I want something. What do I get out of it other than putting my money in and saying, I'm a good guy, I helped? Could we offer something?
I also take the lesson of SETI at home, right? The people who did all of that processing, very honestly, a lot of people were motivated because they had a leaderboard of how many CPU hours people had spent analyzing this data, and you got the competitive spirit in there. I think this is a community of competitive people.
Yeah, and I think also if you want to, for example, deploy these at science museums, which have a chance of funding them and keeping them on the air for a long time, you need colorful eye candy, which is what's the space weather look like right now, and some way to display that.
Here's how I'm contributing to it I'm contributing to this way in some small way. Yeah, Rachel.
I'm not sure I have too much to contribute, but I have several whisper beacons that I run more or less continuously on medium frequency and VHF, UHF. I could do a lot more. I'm currently building more antennas, interested in all kinds of propagation experiments. But as far as this group, I have no idea. Nobody's told me what's important. It's sort of like cancer research. Everybody wants to cure cancer, but they don't really know what to ask for. Okay, so right off the surface, yesterday I was watching the displays that showed 4 horizontal and vertical polarized signals and how they changed. I was fascinated by that because it's a question that's come up a good deal in our own little group of engineers up in Northern California. And indeed, I've been planning on doing cross-polarization studies. And I've made several suggestions to Rob, who's really a marvel with all these Kiwi installations. How could we set these up? I can do cross-polarized antennas. I need to be prepared to do it. It requires a certain configuration of the station equipment. And nice thing about beacons, I don't have to be there. They just run and run and run and generate data. But I have to know that somebody wants that. And so if we have more concrete ideas from you people, we can do a great deal with the equipment we have. It's enormously sophisticated. It challenges the imagination. But in terms of integrating with the scientists, we need a little more direction. We can do a lot. The talent in our group is really deep, hundreds of years of engineering experience. You tell us, and we'll find a way to do it.
Sure, I totally agree. And I think we're starting to converge. I think different people have different ideas of what they want to. Like, I would very much like seeing lots more of these Doppler shift measurements from WWV that David Kasdan's working on, because I'm interested in traveling ionospheric disturbances. I would like to have calibrated signal strength measurements of WWV. Also, some way of understanding how the signal strength changes from RBN or whisper. Like, if we could have a whisper station where we know that whatever power level they say they're transmitting at, we can understand what that means, and then how it is on the received side, then that might help tell us some information about how solar flares are affecting the ionosphere. So there are certain quantities that we have. I think, just trying to figure out right now what's the most important ones, and how can we reduce that to something tractable. Because as I've made the point before, all of these things, if you can just record all of the HF spectrum across the entire United States instantaneously and, save it to a disk, we can go back and get all of these measurements just by doing post-processing. But obviously from Tom's presentation, that's not feasible.
Okay, I want to get Rob's comment out of the audience. Go ahead.
I just wanted to add that, we talk a lot about the value of Whisper database, and I've invested a lot of time. I have an 8-channel version of the Kiwi that posts like your Red Pad. It does. But there's actually information. There's problems with using Whisper database. The database itself is poorly maintained. It has terrible query abilities. You really have to pull all the data out of it and do your own query. So, there's an opportunity to help the Whisper community here by doing something to make a better Whisper database. There's also information in the Whisper decode that is not stored in the database. So we're losing, even in the Whisper decode process, we're losing information that is produced by the Whisper decoder from those packets. So I just want to caution people not to be. There's an opportunity and also a warning about not becoming too dependent upon a database that is so fragile and infallible infallible. I'm sorry.
I agree. One quick comment. So Bill Engelke right over here, he does pull the entire Whisper database and has it duplicated, and I've been working with him. So that paper I published that we're handing out over there, that's using queries from his database.
Yeah, there's about 4 or 5 of us are doing. I have my own clone that I do, and I know 2 or 3 other people who clone the database. It's crazy. We're scraping that database because So on the other hand, it's the place where it is. But I think that it would be a great project, a software project, to have one place where somebody scrapes that database. They've been promising SQL or MongoDB, queryable database for Whisper forever, and it's not happening. It's not happening. They're sitting there. We're losing spots because their database goes dead for 15 or for 90 seconds, and the Whisper J decoders everybody uses fail out, so they drop their spots. So there's information being lost in this whole system because of the fallibility of the database itself. And so even there's an opportunity on an IS level for this group, if maybe contribute to the database.
Thank you, Rob. Okay, we're about out of time. One more comment from Tom, and then I'd like Daniel to wrap it up.
So the question to Nathaniel would be, we have things like whisper transmitters that were designed for, I think, kind of a fairly narrow purpose. One could augment perhaps that with a continuous, coherent, well-known frequency, and then transmission that would give you frequency references on more frequencies than just WWV. Would those things, just small tweaks or advancements, would that help you?
I think absolutely. We should try and build on, take what we already have and, just make these adjustments as necessary. If we don't have to reinvent everything, we shouldn't. So I totally agree.
Okay, one comment by Scott. Okay.
Okay. So I'm thinking I would actually add 2 more objectives to your list. Or maybe I should have said this at the very beginning. But the first one we just covered was give the community something back, whether it's Whisper variant of it, help the Whisper community. But like I think you said, the ham community is competitive, and we are competitive. And as I see this in my Explorer post, when we sign up for field day, normal docile teenagers become fierce contesters in like one day when they get on the radio, and it's because they're competing with each other. So that would be an incentive to get lots more people on. And really the objective is get more people with stations. How do you do that? Well, give them something back. And then the last objective would be give us some idea, and we can help with this cost objective, because it helps us just rule out the $10,000 ADCs because we're not going to use those. So we can scrape off the top end and throw that away. Now the question is, how low can we go and have it still be useful? And then we can make a trade-off based upon the cost with what the scientific objectives are.
We just cut parts off the board until it stops working. We months it.
That's the RCA method, isn't
months.
it?
Yeah. Okay, Nathaniel, why don't you wrap up this and...
Okay, go ahead, David.
I do want to get a word in here.
Sure.
Is there an accepted academic publication ethic for acknowledging the input of amateur radio operators and other amateur scientists? And is there perhaps an ethic to be developed here of more formally acknowledging in publication the work of collegiate radio stations so that their cause can be furthered within academia?
David, search for Cornell Ornithology Backyard Bird Count on the web. There is a precedent for how to cite work from a collective. They've worked on it for 20 years.
Okay, everyone. I'd like to thank you very much for participating in this panel. We know that there are many more comments and much more discussion. So one thing I'd encourage you to do if you'd like to give some more input, you can go on hamsci.org right now, and there is a link for the Personal Space Weather Station. You can join the Google group there, and you can feel free to just give your input there, and then that will be on a permanent record, and it'll also allow for some more discussion. So continue discussing tonight, and thank you very much.
Okay. What's next?
What's next? I will turn it over to the Case Western people to talk about what's next. Is Christina here?
So one of the things I was hearing is, as we pick this price point, and as he was pointing out in his presentation, we can plug in different levels of technology. Somebody here has mentioned a version number of what we're doing, and that's an important thing. Can the science be furthered by a very inexpensive sensor at version 1 or level 1, and also furthered by that level 5 sensor? So $10,000, $100 sensor is good as $50,000. Right. Yeah.
Okay. Over to Christina.
Looks like we have one more question. Catch that, or?
What do you want to say?
No, just as long as you're making sure that as you're recording that data, whether it be from a $1 sensor or a $500 sensor, that in the metadata you're saying, this is the sensor that I'm using, this is how it's calibrated. That way, as you're going through, if you need that higher quality data, we can pull that. But if it doesn't matter, then you have that too. That's going to be crucial.
All right, folks, if you direct your attention back that way, you will see some cardboard boxes that are filled with really delicious burritos. Those are for eating. We shall eat them and continue this conversation in less formal context, and then we shall adjourn at probably 6:30 to Strosacker Auditorium for our closing remarks and our screening of the movie Contact on 35mm. We will walk together.
And there's also an exam session?
Yes, anyone who would like to take an exam should come into the conference room where we are giving one now.
Thank you very much.